Chapter 9, we are working on vertex form now with quadratics and parabolas. So I'd like you to try this warm-up, which is describing the transformation and how the graph differs from this parent function y equals x squared. And then state the vertex, the domain and range, etc. State the domain and range, I guess, just of example 1 right here. So pause the video, try these questions, and then restart the video to see if you got the answers correct. Okay, so the transformations, remember, the parent function sits here right at 0, 0, okay, for the vertex. So this graph right here has shifted 2 to the left. So we say it went left 2. Remember, it's the number inside the parenthesis that shifts it left or right, the opposite of what you think. So plus 2 goes to the left 2. And then the number outside shifts it up or down, exactly what you expect. So this is going up 4. Remember also that if what's in front of the parenthesis, or what if the a value is negative, then it also opens down or is flipped. So those are the transformations that you should describe. Okay, the vertex then is left 2 or negative 2, up 4, 4. So you went left 2 and you went up 4, and that's where you ended up. Now the domain is your x values, and they keep going. The x values keep going in each direction, okay, both positive and negative. So for parabolas, just like absolute value, it's all real numbers, and that is the symbol for it. The range is the y values, and the y values never go lower than this point right here, which happens to be the y value of your vertex. So my y values, how do they compare to the the 0? Oh, sorry, I did the wrong vertex. Sorry. So my vertex right here is, I was doing the parent function, sorry. So my vertex never goes, and my y values never go above that value. So my y values compared to 4 are less than or equal to. All right, the next one, the transformations, this number in here is shifting it right or left. It's the opposite of what I think, and so it is going to the right 1 space, and this is making it go up 5. Okay, notice that what's in front here is not negative, and so it is not flipped over. So that's kind of some of the things we worked on yesterday. Now we're going to use that knowledge to actually graph parabolas and quadratic functions in both vertex form and standard form. So we're still going to work on stating the transformations, okay, in vertex form, and now we're going to add graphing in vertex form. So we're going to use a t-table and the vertex, knowing the vertex, because that's going to be our point that we're putting in the middle. And then we're also going to work on just stating from the graph, after we've graphed it, the axis of symmetry, the min-max value, and again the domain and range and vertex. Okay, so this is how, remember, this is how we graph a quadratic in standard form. Okay, the y-intercept is our c value. And this comes from standard form, which is y equals ax squared plus bx plus c. So our c value is negative 3. So our y-intercept is negative 3. It's also the ordered pair, 0, negative 3. So that is my y-intercept. And I like to plot these as I go. So that means I know my quadratic is going to cross the y-axis right there at negative 3. My axis of symmetry is the equation of the line x equals negative b divided by 2 times a. So again, here's my a, it's the number in front of the x squared, and my b is the number in front of x to the first. So I'm going to have the opposite of b, so I'm going to take the opposite of 2, so negative 2 over 2 times my a value of 1. Negative 2 divided by 2 is negative 1, so my axis of symmetry is the equation of the line x equals negative 1. And yes, you need that x value because it's an equation of a line that goes through the x-axis at -1. And your vertex is going to be somewhere on that line. So that means our vertex x value is -1. So it's -1 something. So I need to find the y value when x equals -1. So I take the -1 and I put it into this equation. So I would take -1 squared plus 2 times -1 minus 3. And that would give me 1 plus -2, which is going to give me -1, minus 3 more, which gives me -4. So again, I plugged in that value, and so my y value is -4. So I get -1, -4, there is my vertex. Okay, so is that a minimum or maximum value, and what is it? Well, my values are never going to go below this point. So that is actually a minimum value. So it is a minimum, and what is that minimum value that they never go below? And that would be -4. All right, let's work on the x-intercepts. The x-intercepts are where they cross this x-axis. Those are the values of y when x equals 0. So now I put 0 in for y, which is the same as my f of x, and I take my x squared plus 2x minus 3, and I factor it, okay? Now I look for a greatest common factor, but there are no common letters because there's not an x in the third term, and there's not a number that goes into both 1, 2, and -3. So these are the kind that I look for, two numbers that are going to multiply to -3 and add up to 2. So, well, multiplying to -3 would either have to be 1 and -3 or -1 and +3. And which is the combination that would give me +2, and that is this one right here. So those are the numbers that I put into my parenthesis with my variable. And now I'm going to use the zero product property to solve. And the zero product property says if two things multiplied together equal 0, then either this would have to equal 0 or this parenthesis would have to equal 0. So I set my parentheses x minus 1 equal to 0 and x plus 3 equal to 0, and I solve them. Now, you might be able to solve these in your head when they're that simple. So one of my zeros is 1 because that would be the value that I would put in here, subtract 1 and get 0. My other value would be when x equals -3. And again, if I put -3 in for x, -3 plus 3 is 0, and 0 times anything is 0. So my x-intercepts are 1 and -3. And of course, I could also write those as ordered pairs. That's 0, 1 and -3, 0. So I'm going to graph those as well. I have 1, 0 and -3, 0. Notice these are both 2 spaces away from the axis of symmetry, just on opposite sides. So we actually can put another point 1 space away from our y-intercept, and now we have 5 points to graph. And that's usually the standard that we want to have. So I'm going to sketch in my quadratic. My domain, again, is my x's, and my x's keep going in both directions, so it's all real numbers. But my range, my y values, never go below -4. That's that minimum value of -4. So my y values are greater than or equal to -4. So that's how we graph in standard form, okay? And that's what we worked on a few days ago. And so now we're going to work on graphing in vertex form. So again, this is just review, and this is telling you that when it's in vertex form, the h value inside shifts it left or right, the opposite of what you think, okay? The k value on the outside moves it up or down, and exactly what you think. And the a value right here is what tells us whether it flips over. If a is negative, then the parabola is flipped. So we can use that idea to put the vertex in the middle of a t-table, and then we can choose additional values for x, plug them in to get the f of x or y values. So this is kind of the steps that we do. We state the transformations so that we can put the vertex into our t-table. Okay, then the vertex will go in the middle of the t-table, and then we're going to pick other points. We're going to find two values that are smaller x values and two values that are larger x values, and we're going to plug the x values into the equation to get the y values. And then we plot all the points. So let's try it with an example. First of all, it says state the transformations. All right, so what's happening to this graph? Well, this number, -4, is shifting it left or right, remember? And it's the opposite of what I think. So this is going to be -4 is going to move it to the right 4, and that +3 is moving it up 3. There's no negative in front, so it won't be flipped over. So where would my vertex be if my original vertex is at 0, 0, but now I am shifting to the right 4, 1, 2, 3, 4, and up 3, 1, 2, 3, here's my vertex. And remember, the vertex is always the opposite of h, so that would be 4, and k stays the same. So you can see my vertex is 4, 3. So now what we need to do is we need to pick two numbers larger and two numbers smaller than the number 4. So a number larger would be 5 and 6. Numbers smaller would be like 3 and 2. So now what we do is we take the 2 right here and we plug it into the equation for our x value and solve it. So what that's going to look like is 2 minus 4 squared plus 3. Now, if you type this into your calculator exactly like you see it, you will not make as many mistakes. If you try to figure it out on your own, you might. So put parentheses 2 minus 4, and then square that, and then add your 3. And that should give you a value of 7. Okay, so now we're going to put the 3 in there. 3 minus 4 squared plus 3. So again, type the whole thing into your calculator so you make fewer mistakes, and that gives you 4. Now I'm going to put the 5 in there. So I would have 5 minus 4 squared plus 3. Again, use those parentheses correctly, and that gives you a value of 4. And when I plug 6 in there, that gives me 7. So I'm going to plot those points. So I'm going to have 6, 7, and I'm going to have 5, 4, and notice I have my other 2 points are 2, 7, and 3, 4. Oops. Not there, right there. And notice, okay, again, now I have my now I have, I was going to use a different color here, my 5 points, and I can sketch my parabola. Again, notice the axis symmetry right here, and then also notice that this point right here is 2 spaces away from the axis symmetry, and so is this point. And that's why you see that you have repeating values right here. All right. So this is kind of, again, the notes to remind you of what the axis symmetry is. The axis symmetry is the h value of the vertex, okay? So your axis symmetry, if we go back to this one, goes through at the same point right here as the x value of your vertex. And so your axis of symmetry is always going to be written as x equals your opposite of your h value, or your h value from your vertex, I should say. The minimum or maximum value is your k. The domain is all real numbers, and the range, again, is when your y values are less than and equal to or greater than or equal to that y value, depending on if it has a minimum or a maximum. And you can memorize this, okay? But you really don't need to. You can just look at the graph and think about the graph and figure out what your range is. All right, so let's start by stating the transformations of this. So the transformations here, we have +1, and that shifts it left or right. This is actually going the opposite of what you think, so it's going to go left 1, and it's going down 2. So if my vertex is going left 1 and down 2, here's where it would be. It would be at -1, 2. And again, remember, when we go x minus h squared plus k, okay, is the y value of your vertex, and the opposite of h, okay, is the x value of your vertex. So there's your opposite of h. So h is 1, or you could think of this as minus a negative, so we have to subtract h, and that's why it's -1. Again, now we're going to pick two values larger and smaller. So what would be 1 bigger than -1? Well, that'd be 0 and 1 more. And then what would be 1 smaller would be -2 and -3. So again, I am going to take -3 right here and plug it into the equation for x. Write the equation exactly like you see it, parenthesis, -3 plus 1 squared minus 2. Type all of that into your calculator. -3 plus 1 in parentheses squared minus 2 equals, and that gives you 2. Okay, then put in your -2. You'll make far fewer mistakes if you just use your calculator on this. That gives you -1. Now we're going to put 0 in. I know that you guys could do these without your calculator, but it's also very easy to make a simple math error. And so when we do this, we get -1, and when we plug in 1, we get 2. So I'm going to plot those points. I have I'm sorry, I put my vertex in here wrong. That's -2. I graphed it correctly, set it correctly, but just actually filled it in the table wrong. So now let's go back here and plot these points. I have 0, -1. I have 1, 2, which is right here. And then I have the red points, which are -3, 2, and -2, 1. So again, if you look at this axis symmetry that's going through the vertex, notice how those points, if I can actually plot them correctly, this blue one should be 0, -1. Got that one. And 1, 2, oh sorry, it was a red one. And that is -1, -2, -1. There we go. All right. So notice how the red and blue points are the exact same distance away from that axis of symmetry. And that's how we know we've done it correctly. Okay, so now what is that axis of symmetry? The axis of symmetry goes through right here at that vertex of the x value being -1. So it's x equals -1. That minimum or maximum value right there never goes below this point right here, which is the y value of my vertex. So my minimum or maximum value is -2. My domain is going to be all real numbers, and my range, my y values never go below, so they're greater than or equal to -2. All right, so we have a couple additional examples here. I'm going to have you try this one on your own. I'm going to get you started on this one, and then I'm going to have you try the rest on your own and check the notes, and then I will do one more, just so this video doesn't get too long. All right, so the transformations for this particular one is, notice that there is nothing in the parenthesis, okay, that's squared, so it'd be like x minus 0. I'll see if I can write that a little bit neater. So it would look like x minus 0 squared, okay, and then minus 4. And I still have that negative out there. So what that's telling me is that it didn't shift left or right at all. But what it did do is go down 4. But look at this. It's also a negative, so it's flipped. So you should expect it to be flipped upside down. So that means since it didn't go right or left at all, and my h is 0, my vertex is going to be 0, negative 4. So I'll go ahead and plot that. 0, negative 4. There's my vertex. Okay, my axis of symmetry is right here. Okay, so that means it goes through the vertex and it goes through that or that x value. So my axis of symmetry is going to be x equals 0. So now we need to go ahead and pick some points. So pick 2 values that are greater and 2 values that are smaller. So 0, 1, 2, and then 0 we'd have negative 1 and negative 2. I'll use a different color for those. Now, I'm going to have you try the rest of this on your own here, but I'm going to show you how to put in that first negative 2. So this is what, again, you're just recopying. You have the opposite of, and then you have your x value squared. Remember, anytime we square something, even when there wasn't a 0 in there, we still need parentheses around what we square, and then minus 4. So try this on your calculator. Make sure you get this right. So you'd have the opposite or negative symbol, and then parentheses, minus 2 parentheses squared, and then minus 4. So that will give you negative 8. Now, if you enter this incorrectly, you're going to get a different answer. So now that you've tried that, I want you to try the other 3 values and plot your points, fill in the domain and range and minimum value, and then check back to the notes for the information to see if you got it correct. All right, we're going to try this one last example. I'm going to have you pause the video right now, try the whole entire thing on your own. Then when you get stuck, you can restart the video to get some hints and then stop it again and see if you can do some more work on it. And when you're all done, then start the video back up and I will explain each and every step. Okay, the transformations for this, the number inside the parentheses shifting it left or right, the opposite of what you think. So this is making it go left 2. And the number on the outside is making it go up or down. In this case, it's going up 5. Remember, there's a negative out front, so that means it's also flipped. So those are the transformations that you would state, okay? Then, from the transformations, if it went left 2 and up 5, then my ordered pair would be negative 2, 5 for my vertex. So going left 2, 1, 2, 3, 4, 5, that's where my vertex is right there. So then to get my other points, I am going to choose 2 values larger and smaller. What would be smaller would be negative 3 and negative 4. What would be larger would be negative 1 and 0. So when I put in each of these values, when I put negative 4 in, I'm going to write it like this. Negative, or the opposite of negative 4 plus 2 squared plus 5. Again, I would highly encourage you to just type this into your calculator. So take and put your negative symbol parenthesis, then negative 4 plus 2 parenthesis squared plus 5. And that should give you a value of 1. So at negative 4, when x is negative 4, y is 1. Now we'll put negative 3 in there. So the opposite of negative 3 plus 2 squared plus 5. So again, you can type that all into your calculator, and that will give you 4. So at -3, we're at 4. Okay, now let's work on the other points. We would put in the opposite of -1 plus 2 squared plus 5. And that will also give us, if we do it correctly, should also give us 4. So -1 is also 4. Again, notice how those are the same distance away from that axis of symmetry. Okay, that's going right here. So now let's do our last point in red. And the opposite of 0 plus 2 squared plus 5 gives us +1. So 0 is 1. Okay, oops. 0, 1. There we go. All right, so now I have my 5 points. I graph it. I give the axis of symmetry is the equation of the line, x equals -2. Remember, that part and that part should match. Okay, the domain is, the minimum value or maximum value. My values never go above this point on the y-axis, which is 5. So my y values compare to 5. How? Well, they're always less than or equal to 5. My domain is all real numbers, and my range, I put my range here, less than or equal to 5. My minimum value is just 5. I think I kind of talked about that together. Okay. So hopefully that gives you some information, and you can now go ahead and complete your homework. But this is the end of the video for graphing in vertex form and standard form.